You step out of the lander and your boots touch a surface no human has ever stood on before. You are on Mercury, the closest planet to the sun, and the silence around you feels heavier than any silence you have known on Earth. There is no wind to carry sound, no atmosphere to soften the light. The sun above you is not just bright, it is enormous, more than 3 times the size it appears from Earth, and its glare floods the gray landscape with a harshness that makes you squint even behind your visor. You take your first steps, and immediately something feels different in your body. Mercury's gravity is only about 38% of Earth's. Every step launches you slightly higher than expected, and you have to relearn the simple act of walking. Scientists have confirmed this through decades of spacecraft measurements, beginning with Mariner 10 in the 1970s and continuing with the Messenger mission, which orbited Mercury between 2011 and 2015. This is Category A, confirmed scientific fact. Your body weighs less here, but the danger around you has not lessened at all. As you look toward the horizon, you notice the sky is pure black, even though the sun is blazing directly overhead. This is because Mercury has essentially no atmosphere to scatter sunlight. On Earth, the air around you bends and spreads sunlight in every direction, which is why our sky glows blue. Here, there is nothing to do that scattering. So you stand in a world where it is simultaneously blinding daylight and starless night, a contradiction your brain was never built to expect. But that is only the beginning. As you walk further, your suit's instruments alert you to wild temperature swings. Mercury's daytime surface can soar past 430 degrees Celsius, hot enough to melt certain metals. Yet step into the shadow of a crater wall, and temperatures plunge toward negative 180 degrees Celsius within moments. This is confirmed by thermal data collected from orbit. Without an atmosphere to trap and circulate heat, Mercury cannot moderate itself the way Earth does. You are standing in one of the most extreme thermal environments in the solar system, and the line between survivable and lethal is sometimes just a few steps away. You glance down at the ground beneath your boots. The regolith, the loose layer of dust and broken rock covering the surface, is dark gray and surprisingly soft in places, shifting slightly with each step like dry volcanic ash. Mercury's surface looks remarkably similar to our moon at first glance, covered in countless impact craters that have built up over 4.5 billion years. Without weather or plate tectonics to erase them, these craters remain almost perfectly preserved, like a frozen photograph of the solar system's violent youth. As you continue your traverse, you arrive at the rim of a massive crater, one of many that scar this world. This is Caloris Basin territory, one of the largest impact structures in the solar system, stretching over 1,500 kilometers across. Scientists believe the impact that created it was so powerful it sent shock waves through the entire planet, and on the exact opposite side of Mercury, a strange jumbled terrain of hills and cracks exists, which researchers nickname the weird terrain. Current evidence suggests these seismic shock waves converged there and fractured the surface from the inside out. This remains a leading hypothesis, Category B, but it shows you that even a single ancient collision can reshape an entire planet. However, something even more surprising waits for you near the poles. You travel toward Mercury's North Pole, where despite the planet's blistering daytime heat, permanently shadowed crater floors never receive direct sunlight. Radar data from Earth-based telescopes and confirmation from the Messenger spacecraft revealed bright deposits in these shadows, and scientists determined they are made of water ice. This is confirmed scientific fact. Billions of years of comet and asteroid impacts likely delivered this ice, which then became trapped forever in these permanently frozen pockets, never warm enough to melt or evaporate. Standing at the edge of one of these craters, you realize you are looking at frozen water on the planet closest to the sun, one of the most counterintuitive discoveries in planetary science. Your communication delay back to Earth varies depending on where Mercury sits in its orbit, but it can range from about 5 to over 12 minutes one way. This means a simple question to mission control and its answer could take 20 minutes or more round trip. Any emergency response has to come from your training, your equipment, and your judgment in the moment, not from someone reacting live across millions of kilometers of space. As you make your way back toward the lander, you notice something strange happening with the sun's position. Because of Mercury's highly elliptical orbit and slow rotation, the planet experiences a rare phenomenon where the sun appears to rise, pause, briefly reverse direction, and then rise again, something scientists call the Mercury sunrise effect. This occurs because Mercury's orbital speed temporarily exceeds its rotational speed at certain points near the sun. This is confirmed by orbital mechanics and has been calculated precisely using data from MESSENGER. Watching it happen in person, you understand why early astronomers found Mercury's behavior in the sky so puzzling for centuries. Your suit also reminds you, through constant radiation warnings, that you have no natural shield here. Earth's thick atmosphere and strong magnetic field block most harmful particles from the sun, but Mercury's atmosphere is essentially non-existent, and its magnetic field, while real and measured by spacecraft, is far weaker than Earth's. Solar wind particles bombard the surface directly, contributing to space weathering and posing serious long-term radiation exposure risks to any future explorer. This is one of the central engineering challenges scientists are still working to solve for sustained human visits. A clear example of a future possibility still constrained by present-day technology, Category C. As you prepare to leave the surface, you take one final look across the cratered plains, the towering sun, and the impossible black sky above it. You think about how this small, dense world, similar in size to our moon, but with a surprisingly large iron core that makes up nearly 85% of its radius, has forced scientists to rethink what they assumed about planet formation. Current research suggests Mercury's outer layers may have been stripped away by an ancient, immense impact, or that it formed closer to the sun's intense early heat than other planets, leaving it with an unusually dense composition. Both remain active hypotheses. Scientists continue testing using data from missions like BepiColombo, which is currently studying Mercury's surface and magnetic field in greater detail. Mercury teaches us something humbling. It is not simply the hottest leftover rock baking near our star. It is a planet of extremes and contradictions, a world that is brutally hot and bitterly cold within the same hour, blindingly lit and starkly black-skied at once, ancient yet still revealing new secrets to scientists with every passing mission. Walking its surface, even in imagination, reminds you that our solar system holds far more complexity in its smallest, closest neighbors than we ever expected. Before you climb back into the lander, you take a moment to consider what survival here would actually require beyond the single afternoon you have spent on the surface. Any future explorer would need a suit capable of reflecting away extreme heat while also retaining warmth the instant they stepped into shadow, a level of thermal engineering far beyond what current spacesuits, designed primarily for the moon and low Earth orbit, can handle. Power would likely come from solar panels, since sunlight here is roughly 6.5 times more intense than on Earth. But those same panels would need careful shielding from both heat damage and the relentless bombardment of solar particles. This is a real engineering frontier, Category C, future possibility grounded in today's science but not yet solved. You also think about why anyone would choose to come here at all, beyond curiosity. Mercury's permanently shadowed polar ice deposits could one day serve as a resource for water, oxygen, or even rocket fuel, should humanity ever establish a research outpost this close to the sun. Its position also makes it an exceptional natural laboratory for studying how the solar wind and intense radiation shape a planet's surface over billions of years. Knowledge that helps scientists understand space weathering on airless worlds throughout the galaxy, including the moon and many asteroids. Current mission planning, including ongoing analysis from BepiColombo, focuses on answering these very questions before any human visit could ever be seriously considered. You also notice, standing here, how strange your own shadow looks. Because Mercury has no atmosphere to diffuse light, your shadow is razor sharp, with an edge so crisp it looks almost cut out and pasted onto the ground. Photographers and scientists studying the Apollo missions on the moon notice this same effect, since both worlds share the same airless clarity. It is a small detail, but it captures something essential about Mercury. Nothing here softens, scatters, or blurs. Every line, every shadow, every temperature swing exists in its rawest possible form. As your time on the surface comes to an end, you take one last reading from your suit's instruments: surface temperature, radiation exposure, structural integrity, all the practical numbers that stand between exploration and disaster. Then you turn back toward your ship, carrying with you the strange experience of having walked on a world defined entirely by extremes, a planet where the nearest star to humanity reveals both its brilliance and its danger in equal measure. Mercury teaches us something humbling. It is not simply the hottest leftover rock baking near our star. It is a planet of extremes and contradictions, a world that is brutally hot and bitterly cold within the same hour, blindingly lit and starkly black-skied at once, ancient yet still revealing new secrets to scientists with every passing mission. Walking its surface, even in imagination, reminds you that our solar system holds far more complexity in its smallest, closest neighbors than we ever expected. As future missions continue to study Mercury, each new finding adds another piece to understanding how rocky planets, including our own Earth, are born, shaped, and changed over billions of years. The closest planet to our Sun, it turns out, still has plenty of distance left to teach us about the universe we live in.